In this video, I'm going to introduce the override keyword, which is a contextual keyword that allows you to explicitly specify overriding virtual functions. Override is a contextual keyword because prior to C++11, it may have been used as some sort of identifier. From our previous discussions, you'll remember that virtual function signatures must match, and this will be enforced by the compiler if you use the override keyword. If signatures do not match, you will get an error. The override keyword follows the signature of the virtual member function declaration. So in other words, it comes last or after the parentheses or after the const if the function is const qualified. As you can see in the example at the bottom of the slide, we specify a virtual member function as an overriding function using the override keyword only in the class definition. In other words, where the function is declared or defined, that is if the member function is also defined in the class definition, but we don't repeat the override keyword in the definition of the member function, that is if the member function is declared and defined separately, right? That is whether the member function is defined in some other .cpp file or the same file, so maybe in the same header file. Again, you only add the override specifier once, that is where you declare that member function. If your program is really complex, you may have a huge inheritance hierarchy, like we've seen in Unreal Engine for example. It's easy to make a mistake where you make a slight change to your function signature. Maybe you forget to add the const at the end, maybe you change the parameters, but you want to make sure that that function is overridden so that the appropriate function will get called. Again, in that case, you use the override specifier, not in the base class, but in derived classes. That is where you actually override the functions. In this example, I have the base class again, so I have a virtual toString function, which will print out base toString, and then derived, publicly derived from the base class again, just like in the previous examples. And then I have the virtual void toString, also const in the derived class. This is going to print out derived toString. And then in main, I declare base pointer, which is a pointer to type of base, but on the heap I allocate a new object of type derived. Then I do base pointer toString. If I build and run this, we can see we get derived toString. And I'll scroll up, and that's because we are using polymorphism, so we have these virtual keywords. Again, this is a simple example. Let's say we have a huge inheritance hierarchy, and maybe we derive from base and we intend to override this toString function, but the signature does not match. So we may remove the const and build and run. As we've seen before, we'll get the toString function as defined in the base class, so base toString, instead of the one that we may expect, which is derived toString. Of course, your formal parameters form part of the signature as well. I'm just using const as a quick example, but you can do a variable change as well. So let's say we have a variable such as int(x) with a default argument. Build and run. Once more we get base toString. I'll just go and remove that. Just make sure that the toString prototypes match again. And then in the base class, I can also make a change. So let's say later on I remove the const for some reason, but I don't go and update that in the derived classes. If I build and run now, once more we get base toString. So the takeaway here is that the program compiles, right? We don't get an error when we compile the program. It's simply not going to behave as we would expect when we run the program. And that is where the override keyword comes in. I do virtual void toString const override. You can already see a red squiggly member function declared with override does not override a base class member. Why does it not override a base class member? Well, that's because the signature does not match. We do not have const at the top here, but here we do have const. That is in the derived class. So if I Ctrl B to build, we'll get an error. Method with override specifier override did not override any base class methods. Of course, if we make sure that those signatures match now, virtual void toString const, and we do override in the derived class, if I try and build and run now, this will work fine. We get derived toString. And this is also very handy for documentation purposes, so that the reader or programmer can understand, okay, this function is overridden. And it is also virtual. Again, virtual does not actually have to be here. It will still be overridden, like this. We can write it like that and build and run, and you'll see this will work fine. Undo that, but we add virtual here also for documentation purposes, so that the reader or the programmer can see, okay, this is a virtual and overridden function. Of course, a similar thing if I remove const here. Once more we'll get that error. Ctrl B to build, and we'll get that error again. So just add that back. Or if you change the formal parameter list, so I do int x is equal to 5, build and run, and we get the same error. Method with override specifier override did not override any base class methods. So the compiler will enforce the signature to match. And in that way we ensure that we call the appropriate functions when we actually run the program, the appropriate overridden function. Now why did I mention that override is a contextual keyword? Well, that's because we can do something like this. Int override is 5, and I print that out. Now of course I do not recommend that you do this. Build and run that. You'll see it prints out fine, we get 5. Okay, in previous versions of C++, so prior to C++ 11, override may have been used as an identifier in C++ programs. And of course a big thing with C++ is backwards compatibility. So they made the override keyword a contextual keyword. But again, I do not recommend that you actually use override for your variable names or anything like that. Okay, I hope you found the section interesting, and I'll see you next time.